All right, 16. A tower consists of cubes piled on top of each other. There are no gaps. After the tower is painted on all sides, including the bottom and backs, it is cut into individual cubes. And how many cubes will have been painted on exactly 3 faces? Well, let's go through this individually. This cube will be painted on 1, 2, 3, on the back 4, 5. So we know this does not work. Let me get a smaller, there we go. This one right here is going to be painted on 1, 2, 3, and then on the back side 4. So we know that that doesn't work. This one here is going to be on 1, 2, on the other side 3, but the top, side, and bottom are all covered. So here's 1. I'll put a check, how's that? Well, how about this one? 1, 2, 3, and the rest are covered. 1, 2, no. 1, 2, 3, yep. 1, 2, 3. So right now, I am looking at, sorry, as I fumble with my papers. Right now I'm looking at 1, 2, 3, 4 that have the correct painting. So then on this one, so right now we're at 4. 1, 2, 3. Yes. 1, 2, no. 1, 2, 3. Yes. 1, 2, no. 1, 2, no. 1, 2 on the back 3. And then on the ones on underneath it, that would only have 1. The one at the corner would have 2. It's okay, so we're good there. So it's just the corners on that one. Well, on this one we have 1, 2, 3, but then the bottom 4. This one is 1, 2, and then the bottom 3. 1, 2, bottom 3. This was 1, 2, 3, 4. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3, and then the bottom 4. So I have 4 on this row, 5, 6, 7, 8, 9, 10, 11, 12, and I'm missing 1. It is amazing how it always happens that way, right? So where is my missing 1? I could swear I'm missing 1. So let's go through this again. So we have this one here. 1, 2, 3. This one here. 1, 2, 3. This one here. This one here. 1, 2, 3. 1, 2, 3. Those have 2. 1, 2, 3. Oh, I know which one. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. What about the one in the corner? So if I were to rotate it around, we'd have something that looked like this. And so this one, this corner, and the bottom corner right underneath there, and there's your 13. So the answer is 13. All right, the numerator fraction consists of 2 numbers. 2, 3, 4, 5, 7, and 9 are your possibilities. You can add, subtract, or multiply them. The denominator contains 2 of the other numbers, and they can be added, subtracted, or multiplied. What is the greatest possible value of the fraction? Well, we know that to have a larger fraction, we need a small number in the denominator. And the smallest number we can get is 1. So how can I get a 1 out of these numbers? Well, 2 and 3 are 1 apart. So we know that 3 minus 2 is going to give me my 1, which means I want to multiply the 2 largest, 7 times 9, so I get 35 over 1, so the answer is 35. That one was much easier, actually, as was this one, although I know lots of people struggled. How many different sums are possible for 10 standard dice? Well, if we have 10 standard dice, the largest number on the die is your 6. And I have 10 of them. So 6 times 10, that's right, is 60. But can you have 60 total numbers or sums? No, because we have 10 dice, and the smallest possible roll is a 1. So that means the smallest number I can have is 1 times 10, which is equal to 10, which means the numbers 1 through 9 cannot happen. Well, if there are 60 total numbers and I've eliminated 9 of them, that means 60 minus 9 is going to give me 51. Last two. A rectangular piece of tin is 9 by 12, and some squares are cut out of it. It's starting to feel a bit like Christmas. Not a big Christmas fan, but oh well. By 2. Well, that means, and it's asking for what is the, so essentially you're going to take these and then you're going to make a box out of it. With no top. That's why you can see in there. Well, what is the distance from here to here? Well, if this is 2 and this is 2 and the whole distance is 12, that means I've taken 4 out of the 12. So we know this is 8. Same logic, 2 and 2. So we've taken 4 out of the 9, so this is 5 with a height of 2. And we're asking for the volume. What is the volume of the resulting rectangular solid? And so we have 2 times 5, which is 10. 10 times 8, which is 80. And remember, you don't need units in these, so it's just 80. Finally, number 20. The cost of a computer club to replace a computer, is $3.15. And it's going to be shared equal by all the members. The school will pay the rest. Great. By recruiting 4 new members to join the club, the cost for each member will have dropped $5. So I have 4 members, 4 new members, and the price will drop $5 each. Well, there are a couple ways to do this, and I think the easiest way to understand would be to make a table. So let's see. And I'm going to cheat here because it's late and I want to go home. So let's say we have 10 members. So we have number of members and cost. So if I have 10 members, they're going to split the 315 divided by 10. I probably didn't need a calculator for that. Right? Well, so 11, 12, 13, 14, 15. That's not what I wanted. So I'm just going to erase that. And I just arbitrarily started at 10. 16, 17, 18, 19, 20. All right. So if I added 4 new members, I would have 14, right? So 315 divided by 14 is 22.5. Has it gone down $5? No, it's gone down more than just $5. It's gone down $9. So I know that's not right. So I know it's going to be substantially more than 10 members going to 14. So let's try 12. So if I have 315 divided by 12, I have 26.25. Let's try 16. So 315 divided by 16, I get 1968. Well, already I can see the cents aren't going to work out. And now it is a little bit less than 5. Huh. Or sorry, no, it's still sorry, it's still larger than 5. What am I thinking? I need to go to bed. Well, let's try 13. So 4 more than 14 is going to be 18. So 315 divided by 18. Anytime now. Oh, it's 1750. Well, guess what? These are 5.
Are you teaching right now?
I'm making a video.
Oh my bad.
Oh no, it's okay. My kids are at the movie downstairs,
Okay.
so I'm just.
Do you have a minute?
Yeah, actually, give me 1 second. I'll finish this.
Okay.
I'm almost done,
Okay.
and then yeah, I'll have a minute. So this is 5 apart. Well, so that means, what was the cost per member before the 4 members joined? Well, it's $22.50 right here, and we just made a table and logicked our way out of it. All right. I hope you enjoyed.